All right, hey everyone, both in real life and online. My name is Andrea, and I am from Story, and appreciate you being here. I know things can get hectic and there's a lot of talks. So today I want to talk about agent-to-agent transactions. Not really going to focus on any specific ecosystem. This is going to be a very generic talk. If you're into AI agents, this could be interesting for you. And yeah, let's just dive in. So before we start, I want to set the context of why we are thinking a lot about AI agents, at least at Story. Because if you think about it, agents are intellectual property. Both the inputs that go into training an agent, both the outputs that come out of an agent, and the model itself, or the multiple models that power an agent, are intellectual property. And so, you know, everything that they create is intellectual property. Everything that they know how to do could be intellectual property. And I'm just setting the context here. Slowly, agents are getting smarter and smarter. If you think about how AI agents are today, especially in Web3, I'm sure you probably will agree that a lot of them just end up being reply guys on Twitter, right? The most famous example is AIXBT, and I think it's a great example. I think they're doing a great job. But a lot of agents are just thin wrappers around OpenAI, Anthropic, Grok, and other foundation models. And while it was very impressive and it created a very strong speculative bubble a couple months ago, the novelty of just being a reply guy is really wearing off quickly. And while this micro bubble is kind of popping, the macro trend of agents is just getting started. And if we look at the current trends, even in Web 2, it'll help us think about where agents are moving towards. Because every major AI company is moving towards agent-first experiences. We see this with OpenAI moving towards operator. And GPT-5 is going to be basically a wrapper around multiple models, and it's going to arbitrate and orchestrate different models based on the task. Things like deep research, right? Hardware companies like NVIDIA are creating essentially supercomputers that you can buy for a couple $1,000s and keep on your desk. So creating specialized models is going to get easier and easier and cheaper. And at the same time, you have these closed source monoliths, that have massive resources, but at the same time, you also have open source models which are catching up quickly, whether it's DeepSeek, Stability AI. And all of these three macro trends are really pushing in a direction where an agent is not just going to be a prompt around a model. If you create an agent on Eliza today, really what you're creating is a character.json, which is a fancy file for a prompt. But we're moving towards proprietary models, proprietary data. Think of maybe medical agents that have access to specific medical data that no one else has access to. And given that they're going to become proprietary, they will have knowledge and know-how that can't be replicated by just changing your prompt, by changing your character.json. And what does this create? What does this cause? Is that agents will be increasingly differentiated and increasingly specialized. And why am I hammering home this concept? It's very simple. When agents become increasingly differentiated and increasingly specialized, and not being able to easily be copied, different agents will need to lean on each other for different tasks. So keep that in mind as we move towards the rest of the presentation. My personal opinion of the phases of AI agents going forwards is, last year and 2 years ago and last year, we were kind of awakening agents. They were, again, prompts around simple models. This year and next is really going to be about learning and becoming differentiated. So being able to really decompose tasks and perform those tasks with specialized agents. And we're going to see the start of a skill economy. I don't know how many of you watched Matrix. I mean, it seems impossible to me that people may not have watched Matrix, but I'm also noticing that I'm starting to get white hair. So if you have watched Matrix, you know how Neo or Trinity was able to implant specific skills when they needed them. This is really going to be what's going to happen with AI agents as well. But in order to get those skills, there's going to need to be a transaction. And again, this is the whole purpose of this talk. And as these transactions emerge and will become more and more commonplace, a whole economy around agentic skills is going to form. So that will also bring with it reputation systems. That will also bring with it more fine-tuned performance. Right now, agents are kind of like open-ended, stochastic, non-deterministic things that you kind of just let loose and see what happens. But in the future, the models will also evolve to be a lot more deterministic and therefore a lot more dependable. And this is the phase that we're calling ascending. So as I said, agents will transact to exchange skills. And skills is really the key word here because transacting is easy, and we'll see why. Transacting on something that's a bit more complex is going to be difficult because communication is difficult. Communication is probably one of the most difficult things that can be done with humans, let alone agents, especially natural language communication. And if you think about how we communicate with natural language, right? I can speak to you, and hopefully you're understanding more or less what I mean, but what you're understanding is probably a little different than what I'm saying. But it's very flexible, right? I can choose my words, you can choose how to interpret them, and more or less, we're going to find each other in what we're trying to say. And for agents, it's very much the same. Everyone can use a foundation model to generate natural language, and everyone can use a foundation model to parse natural language. But it's very expensive in tokens to continuously exchange information via natural language because it's very inefficient. And, as I said earlier, it's non-deterministic. You don't really know what you're going to get, both in terms of output and in terms of understanding. The old way of communicating for programs was APIs. And the great thing about APIs is that they're very specific. They're very deterministic. But they're very inflexible. They're very rigid. You need to implement the exact API call in order to get the output. So what if there was a way to merge these two things? What if there was a way to have the benefits of natural language, but then kind of transition into an API form of communication? And really, if you think about it right now, there is no universal standard for agent-to-agent communication, but people are working on it. So Oxford University, in a research lab with Microsoft, is working on something called Agora protocol. It's a Web 2 protocol. And what their hypothesis is agents should start communicating with natural language, but should transition to basically generated APIs that both agents agree on. So you start with natural language, you negotiate a common interface, and then both sides, both agents implement that interface and continue transacting through the API that they created themselves for themselves and between each other, right? And this is a very interesting concept, and they have the whole research paper. I think they're still in the implementation phase, and we're actually working with them. But just to give you a clear, demo of it, let's say a weather agent or a news agent needs to know the weather from a weather agent. And they're two different models, they don't communicate, and they're just interacting with natural language. They'll start off with natural language, but then they'll agree on, okay, I know that I need weather data, you know that I need weather data, so let's just agree that I'll send you this type of request, and you give me this form of response, right? We both implement it, and from here on out, we're just going to use the API directly. So you save tokens, you save time, you turn it into a deterministic type of output, and it's a lot more dependable. But you have the benefits of starting off with natural language. So communicating is hard, but transacting is actually very easy. If you think about money it's one of the easiest forms of transactions possible. Money is very easy to transact with, and it was the first ever use case used for AI agents. Because first of all, every blockchain was built for transacting on fungible tokens, right? And the first Web3 agents, the first thing they did was create an EOA wallet and start to transact tokens back and forth. Because the transactions are atomic, and once you receive the funds, given that they're fungible, you can do whatever you want with them. You don't need to have any form of meta agreement around how you can use those funds. So that's not the same for intellectual property. And as I said earlier, everything that agents ingest and everything that agents output or can output is intellectual property. And the difference between intellectual property and regular financial transactions or regular asset transactions is with intellectual property comes terms, comes conditions. I will give you this IP, or you can use this IP, but only if, and you can set the terms, right? You can say, you can use it, but only if you use it in this context, or only if you pay me 10% of revenue of anything you generate. And so creating those terms is quite complex, especially if you don't have a way to do it programmatically. Because I first need to get permission to use it, then we need to agree on a certain set of terms, then I need to pay back anything that I owe, and I need to keep tabs on what I need to keep track of. And then any derivatives created off of the IP that I licensed also need to abide by all of those terms. So it's a compounding problem. And in the real world, IP is also complicated and uses a lot of meetings, a lot of lawyers, a lot of back and forths, a lot of Google Docs, or a lot of Word documents. But what if there was a better way? And I said at the beginning of the presentation I wasn't going to, shill any project, but I kind of have to. So, the good news is Story. That's all we're focusing on, which is how to make IP programmable. So all of the terms that an IP has are programmable on-chain parameters embedded in smart contracts, and therefore agents can transact on them, can create condition logic on those, and compose on them. But that's not enough. And this is why I recently wrote a white paper around a transaction control protocol specifically for intellectual property, which I published on Archive if you want to take a read. But I'll give you the very quick TLDR. Basically, it's a agent-to-agent transaction system specifically for intellectual property. And the TLDR is this diagram, which is whenever an agent requires some form of information or IP from another agent that's not a simple atomic transaction but has certain conditions attached, the provider agent can generate and negotiate with the requester agent specific terms, right? And the way that they do that is via a common license format that I'll get into. And they have this negotiation process back and forth. Then when they agree on it, that specific set of information that is requested is registered as intellectual property, and those specific terms are associated to that intellectual property, and the license token is minted by the requester, and therefore there's an immutable proof of what was agreed on and what was transacted on. And what makes it possible is the programmable IP license. So it standardizes commercial terms and metadata. We basically worked with several legal firms to create a standard license, which we're calling the programmable IP license. And all of those terms are parametrized on smart contracts. So the agents can programmatically define those terms without having to parse legal documents. And agent TCP/IP is already being used in the wild. So Luna is already using agent TCP/IP through the Da Vinci agent that is acting as her agent. Within Story, we had a couple experiments around using agent TCP/IP to license training data across different agents to create a new agent, basically merging training data of officially licensed training data and generating a new agent from that. We also had a hackathon a couple days ago specifically focused on agent TCP/IP. I don't know if any of you were at the Super Agent Hackathon. If you were, congrats. Where basically agent TCP was being created and incorporated across all the major agent frameworks. And recently, I don't know how many of you are in the AI space or know about the Model Context Protocol, but Anthropic, which is a very big Web2 AI company, has created the standard called the Model Context Protocol. And what this does is standardizes how specific, basically units of knowledge can be plugged into by different agents, right? So the hosts, which are the applications, can hook into local or remote servers and clients that have specific knowledge, basically going back to the skills that we were talking about. And the great thing about this protocol is that it's completely standardized, so anyone can contribute their specific host, their specific, basically plugin for agents to use. And we implemented one specifically for agent TCP/IP. So the way that it works is the AI agent interacts with the story model context protocol that exposes all of the IP-related information and all the IP-related actions, and the agent itself doesn't need to know anything about IP. So you can generate an image, you can negotiate the license terms between the agents, you can mint it, basically go through the whole agent TCP/IP flow that I showed in the state diagram, but actual live. I don't know, okay. So this is a quick example. Let's see if, let me make it go faster and press play. Oops. Okay. So right now, an agent is requesting a specific type of image from another agent, right? And the other agent is starting the creation process, and it generates the image, and let's say that image is a form of IP, right? Now, once it's created, the agents are negotiating on the specific license terms that image now has, right? And they're negotiating on them, they're agreeing on them, and then it's being registered on Story. And this is the actual Story Explorer where that IP has been generated, that specific image from this demo, with all of the metadata and all of the license terms that were negotiated between the two agents. So what's next, at least for unlocking agent-to-agent transactions with intellectual property? There's two big areas of further research that would love help from everyone in the community. The first one is negotiation robustness. This is also something that with the Oxford team we've been talking about that they're really interested in. Agents, we kind of assume that all agents will be benign and honest, and but the reality is there might be, just as in the real world, there's scammers and badly intentioned people, there's going to be very bad agents going around. And in an agent-to-agent economy, those types of bad actors are going to be especially problematic, especially predatory agents that have very good negotiation skills, for example, right? So working on negotiation robustness between agents is going to be a very important part, and making sure that the negotiation process is fair. And the second one is removing ambiguity. Because, going back to what we were talking about, anything with natural language implies ambiguity. I can tell you something, I've been talking to you for 20 minutes, and every one of you is going to walk away with a slightly different version of what I said. And probably none of those versions match with what I have in my head, right? And a little bit depends on how good I am at speaking, but a little bit depends on just the natural ambiguity that comes with natural language. And so how can agents start to really remove that ambiguity? And we actually see this organically. I don't know if you saw a pretty viral tweet the other day where two agents were starting to communicate, and after a while, they kind of started to agree on a different language. They were like, this language is too slow. Let's start to focus. Let's invent our own language, a language that the humans had no idea how to understand. but was very terse and very efficient for those two agents specifically to transact on that thing. And that's very similar to what the Agora team is working on as well. Time's up. So what's next? Continuing research. We're working with Stanford, we're working with Oxford, and yeah, lots more to come. Any questions? Is there time for questions? No time for questions, but you can come talk to me after. Thank you very much.